Hi, Mr. Lee here. Here's your Khan Academy tutorial for GCF factoring introduction. Okay, so we are starting to factor expressions. The most common way to factor something is to take out the greatest common factor. So this question is, which expression is the result of factoring the expression below by taking out its greatest common factor, right? So GCF, I can write that here, GCF, okay? So if I look at these two terms, I have a 16x squared and a 8x. Okay, it's subtracting 8x, but 16x squared and an 8x. So there are two things being multiplied: 16 times x squared and then 8 times x. So we can break it down to factors. We can work with strict numbers and then also variables. So if I just look at the 16 and the 8, the greatest common factor between those two should be 8. Right, 8 goes into both of them, and it's the biggest one I can. And then if I look between the x squared and the x, one of those x's will go into both, right? An x squared cannot go into x nicely, but an x can go into an x squared. So this is the greatest common factor for these two terms, okay? So then we take that greatest common factor and we say we factor it out. You're basically undoing the distribution process. So we're going to find which expression actually has an 8x on the outside. So it's either going to be C and D, okay? And then with the way we check the answer is you reverse the distribution process. You're going to check, hey, does 8x times 2x actually give me the original 16x squared? The answer is yes, okay? Check the other one, 8x times a negative 1, does that give me the original minus 8x? Yes, okay? So option here is going to be C. Okay, we can already discount this one because multiple choice, but feel free to check all the options if you need to. So that is number 1. Let's do several here. Okay, so Heng was trying to factor 10x squared plus 5x. She found out the greatest common factor of these terms was 5x and made an area model. Okay, so this is like base times width if you're talking, or base times height, length times width if you're talking about the area of a rectangle. So we can kind of break it up. This is basically a visual for your distribution, right? If I'm just looking at the area of this red rectangle, I have one side length here, which is 5x. I have to ask myself, 5x times what will give me the final area of 10x squared, right? So 5x times a 2x will equal the 10x squared. Okay, so that's kind of the first part of this. You're trying to find this whole width length of the big rectangle, you can say, but we're going to separate into these two smaller rectangles. So that's going to be a 2x, right? Because 5x times 2x is 10x squared. And then I'm going to go back to this side length. 5x times what length will give me a 5x? Well, that's just going to be a 1, right? So the overall width on top should be 2x plus 1, okay? Pause the video, slow down if you need to, but it should be a 2x plus a 1 for a total of 2x plus 1 to get those two individual areas that are already given, okay? So that is basically a visual for what's happening when you distribute, right? 5x times 2x, 10x squared, 5x times 1, 5x. Okay, let's check the answer there. Good. Let's do one more. Another GCF. So we have 3 terms now, but that's not going to stop us. So greatest common factor. So 6x squared, 3x, and a 12. Okay, so if I just look at the numbers first, 6, 3, and 12, we should be able to figure out that the greatest factor that comes out of there is going to be 3, right? 3 goes into 6, 3 goes into 12, 3 obviously goes into itself, so 3 is the greatest common factor. And then now let's consider the x's. There's an x squared here, there's an x here, but there's no x on this constant term. So no x can actually come out, right? No x can actually be factored out because it won't even go into this last term. So our GCF just stops at 3, which means our answer, because it's multiple choice, should definitely be here. But we can still check, right? I want you guys to have a deep understanding. Let's check each piece, right? 3 times 2x squared is your 6x squared originally. 3 times a minus x is your minus 3x. And then 3 times a 12 is your plus 12. So that one does work, okay? Let's just double check that. There we go.